first and last name first?
Yeah.
How do you spell it in your title?
Okay. Arnie Gunderson, Gundersen, and I'm the chief engineer at Fairwinds, and Fairwinds has an E in the middle of it, Fairewinds.
Okay.
And I'm retained by the Friends of the Earth to evaluate the steam generators at San Onofre.
What do you have here? What's the simulation?
Well, this is a simulation of what it's like inside the steam generators that have failed at San Onofre. This blue boundary is 13 feet across, and it's designed to show the tube sheet at the very bottom of the nuclear steam generator. It's a solid piece of steel, and it's drilled with 9,700 holes on this side, and then on the opposite side there's another 9,700 holes. And the tubes connect one side to the other, and they're in the shape of a U. So this is called a U-tube steam generator. Now, hot water would come in underneath this through this red pipe, and it would go up through these tubes, cross over at the top of the U, and come down cool on this side and go out through those white pipes back into the nuclear reactor. So inside these tubes is radioactive water. Where I'm standing is non-radioactive water. And heat transfers across the tube to cool the nuclear reactor. Now, we have 3 tubes here. In fact, there's 9,700 tubes inside the San Onofre reactor, and in just the same amount of space. So they're very, very close together. Now, what's happening inside San Onofre is that the tubes are close, and they made design changes that's causing the tubes to hit each other. They're about less than a quarter inch apart, and there's 500,000 gallons of water every minute flowing up through these little channels and getting extraordinarily hot and turning to steam. So the pipes are colliding with each other, and they're also colliding with the supports that are meant to keep them apart. So this whole thing is vibrating, causing the pipes to dent and causing the pipes to fail. San Onofre made a key decision back in 2004 that I believe caused this problem. Right in the center of this steam generator, underneath here was a pillar, a metal pillar called a stay cylinder. They took it out because they took the stay cylinder out because they wanted to get 400 more tubes. They had 9,300 tubes, they wanted 9,700 tubes. When they did that, they changed the flow distribution and caused these tubes to vibrate. Now, the solution, the short-term solution right now, is to plug those tubes. The short-term solution right now is to plug these tubes. They'll send people down below and stick metal plugs and weld metal plugs into the bottom of these tubes, keeping the radiation out of them. That doesn't stop the tubes from fluttering, but it does stop them from leaking because now they're empty. So these tubes are going to continue to collide with each other even if San Onofre is allowed to start up. The long-term solution is to do it all over again, to put a new steam generator in with tubes back to the old design so they don't vibrate.
Arnie, how much would that cost if they did the long-term
Yeah.
solution, just do it all over again? How much would
Well,
Now we're going to
Oh.
oh, okay. So now you want to.
That was a question that popped.
Oh, I know. Yeah.
Cheap.
It would be.
It sounds like them going like this.
Oh, I know. Yeah. Yeah. Okay. Sure.
How close were you to accident there? How serious?
Oh, yeah. There's one other piece that I talked about last night I can share with you.
Yeah, we'll have you.
How
That's where
close
we're
we
doing
were
it.
to a really big issue. How close we were to.
Yes, that's what he's.
We'll have you go back just a bit.
We'll have
Just
you
like that.
answer
You
that.
can look right towards the cannon.
Wait, am
Okay.
I standing in my blood?
Don't worry about me.
Okay.
I'm taking the 3rd shot of it today.
So this time you'll just be.
Okay. Yeah.
Okay, tape roll.
So Arnie, yeah, that question was a good one. How close were we before they were shut down to a really bad accident.
When they shut down, a little pinhole leak in that pipe was leaking at about half a gallon a minute. But there's more than 1,000 pounds pressure difference. And so that little pinhole leak can cut that pipe in less than a day. When the pipe fails, these are like trees in a forest, and one pipe can whip like a garden hose and hit the next pipe, causing it to fail too. And that's when the tubes cascade and fail like that, now nuclear reactor water leaves the nuclear reactor. And it's actually an accident that's analyzed in the safety analysis report. You've got to make that water up. You have to challenge the safety systems and turn on the emergency core cooling.
When that happened, the notice that the media and the public got, it's like, oh, don't worry about it. This is super minor, very minor.
Yeah.
Was that misleading?
I think it was misleading because while the half-gallon leak was very minor, but the half-gallon leak would very quickly cascade into a 1,000-gallon leak, in which case you'd have to evacuate, at least for a day. It's not something that you're going to come home from dinner.
You said the long-term solution was to redo the whole thing. If we really want to solve this problem, not have it happen again. How expensive is that? Why are they hesitant to do that? What's the issue around doing the long-term solution?
What they did to replace the steam generators cost $700 million. The long-term solution is to do it again and do it right this time. It took about 6 months on each nuclear reactor had to be shut down, and I think a lot of lawyers are going to get rich before that happens, because this is going to be a big-time litigation.
Who was in charge of that decision of taking out the cylinder and putting in more tubes?
I think that was back in 2004. The steam generators were degrading. They had to be replaced. Everybody's replacing their steam generators. Everybody's replacing them with this new ally, 690. That was a good decision. But the bad decision was then they tried to cram in 400 more tubes. That changed everything. It changed the flow distribution inside. What they had worked fine for almost 30 years. They only needed another 30 years out of them. And yet they chose to exceed what they had originally planned, and in fact caused the cascading thing that caused this problem.
Let's talk about evacuation plans. I mean, this area, Irvine, here in San Onofre area, do we have a mass evacuation plan? And you said at half a day, this could have been really bad if no one caught it. I mean, do we have any sort of evacuation plan in this area and up there as well?
There's 2 sites in the country that have awful evacuation plans. One is Indian Point right near New York City, and one is San Onofre. Within 50 miles of here, there's almost 10 million people, and you just can't evacuate. You recall that the chairman of the Nuclear Regulatory Commission told people in Fukushima to get out for 50 miles. It's not something that can happen in Southern California. When this plant was built, there wasn't anywhere near that number of people. And what's happened is the community's built up and the plan is not adequate for the new population.
What now? What are they, we're getting updates from you guys. I mean, they have a few press conferences here and there. What's the next step from here that you think they're going to take?
I think they've got to come to the people in Orange County and they've got to say, look, these things aren't going to run this summer. And we need to conserve energy, and there's things we can do to distribute more power into Orange County. But we're not going to start these things up until we figure out what's wrong. That's not something they can do in the next month.
So you think they could be shut down for how much longer? Or this issue's going to go for how much longer?
The people that made this, Mitsubishi, have said they're not going to have the solution. The people that made this, Mitsubishi, have said that they're not even going to have the problem figured out until September. So for the Nuclear Regulatory Commission and San Onofre to think they're going to start it up when the guy who built it doesn't know what's wrong, it tells me that it's going to be at least the fall before this unit starts back up.
And I don't know if this is a question for you or, but let me know if you can answer this question. Summer's right around the corner. People use a lot of power. I know this plant serves a lot of power for a lot of people. Kind of the impact with, summer really just months away.
California went through this in 2001. and you had that 20-20 plan where if you reduced your power by 20%, not only did you save that, but you got 20% more money back. I think you can accommodate the loss of power for the summer here by some smart thinking and some conservation measures that aren't going to hurt anybody.
So, I mean, you kind of went into it there, but what is the message? They're dealing with their own issues here, but for everyday people at home, is the message to conserve power to help out, or what is the message to everyday residents nearby?
Yeah. The message to everybody is that over the summer we're going to have to conserve a little bit. If we're smart about this, between Edison getting power in from other sources and Californians conserving a little bit, this will be a normal summer.
Anything else you wanted to add on?
Yeah, I think I'm good. Yeah, I think we're good. Okay. It's nice to meet you.
Day.
Yeah.
Thanks for answering all my questions. You're so
okay.
helpful. I mean, those are
In
questions
short
that
sound bites, right?
Usually I'm like, who can answer this question? But so
No.
this summer, I mean, that's what everyone thinks about. Like, how's this going to affect
Yeah,
me at the end
yeah,
of the day?
yeah.
So conserve power.
And you know, I used to be a senior VP in the industry.
Yeah, thank you for your card.
Oh, okay. You can go up on our site was nominated by Huffington Post to be the best nuclear site in the country.
Yeah.
So
You explained it so well. I mean, this stuff.
well, I was a nuclear. I was a nuclear whistleblower. And, you know, I lost my job. We lost our house. We went bankrupt. The whole bit. And the Nuclear Regulatory Commission, John Glenn had hearings. So when he was a senator, and he found out that they were taking bribes and that they deliberately botched the inspection about my claim. But anyway.
But
anyway, how was the play, Mrs. Lincoln? We need a place to live.
Yeah.
So I continued nuclear consulting at night, and I became a boarding school teacher, and for kids with dyslexia. So there's nothing like teaching physics to kids with dyslexia to get the message across. My son was dyslexic. Keep it simple, get to the point.
That everyone.
Yeah,
Wow,
yeah. So okay, that's how we got to where we are. Yeah.
These are a gift from the author, the guy behind it.
Oh my God.
Everything you wanted to know. Different terms.
Thank you so much. Thank you.
And your questions were just wonderful.
I mean, it's a question. I have to think about the questions. What does everyone else want to know? How is this going to affect me this summer?
Yeah.
When I turn my AC, will it work? Am I going to have a massive blackout like we have?
Yeah.
I think there was a really bad blackout.
And I should tell you, inside San Onofre, these are 20 feet high. We just couldn't model it 20 feet high.
Why put more tubes? More power?
I call it a stealth power upgrade. They were planning a year or two from now to get more power out of this plant.
So
That's why.
More.
Yeah,
They just
more.
They got a little greedy there.
They got a little greedy, and this is a case of
efficiency by about 4%.
yeah, not the efficiency. The output would have gone up by 4%.
Okay,
Right.
so that's a good one.
Right.
So if this had worked perfectly, they were aiming at getting a 4%
More power out.
more power out of it.
Right.
That's not worth it.
That's not worth it. Right. And now they lost a half a year in output.
Ah, that's
Right.
really interesting.
Right. Yeah.
But the other thing I think is really key is the fact that all we hear is that, oh, there's a little leak, minor amount of radiation, but they don't.
So are we good? We gotta go?
We're not close to it.
You're my man.
That was perfect.
You're right.
So is that good?
Excellent numbers, great numbers of power loss through the grid, national grid. Do we lose like, I've heard as much as 10% through the grid?
You lose 10% through the grid. 10%. So if this is 33%, it's effectively 30% when it gets to your house. You're losing 10% of what this thing generates. It's 33% efficient, so it's really only 30% when you look at the loss through the pipe as well. Yeah, 10%. But see, I'm a big fan of these things called bloom boxes, which is a catalytic converter that sits in a neighborhood. It's about the size of a truck, and it's 80% efficient, and it converts natural gas into electricity. And you don't need central station. You can have your peaking with gas firing these things, and then run the rest of it off of windmills and solar with smart grids interconnected. These guys don't want to do that. You know, this is a 20th century technology of these big power plants. The 21st century doesn't need that because we've got computers and integrated circuits now. And, you know, we can have a distributed grid as opposed to big power.
Have you read that gal's book, Baker, wrote that book, When the Lights Go Out?
No.
I just heard
Send me
the other day. I'll send it.
Send me the link. Yeah.
Yeah,
When the
it's
lights are annoying. Can you actually hear them? Do you think? Boom.
Yeah, there'll be a little bit, but
Can you hear 'em? Okay.